In this lesson, we're going to look at how can I write an algebraic expression to predict the next term in a sequence. So we're looking at, when you think of a sequence, you're thinking of like a series of possibilities. You know, a lot of times your first sequences are like triangle, circle, triangle, circle, triangle. What's the next thing? Oh, it's going to be circle based on the pattern. So in this case, we're looking at, these different items would be called your terms. And then this sequence itself is like the whole list of terms. Now in this case, we're going to look at this example here. Josh would like to add more trains to his collection. The cost of each car is $8. So let's see just like how much it would cost to buy one car, 2, 3, 4, and 5 cars. So to do that, you start out, okay, so one car would be 8, and then 2 cars would be, let's mark this as, would be 16, 8 times 2. And then the third car would put it up to 24. And then if you got a fourth car, you'd be at 32. And then your fifth car would be $40. So, I mean, we're just counting by 8s, multiplying by 8s in theory. So, like, what's the process being done here? I mean, you could say you're either adding 8 each time. You could say you're taking the number, like, third. So you're doing that times 8. There's different ways you can think about this one. Now, in a situation like this, what you want to do is you want to think about this word here, the variables. Variable means things that change. Oops. So a variable is something that's going to change in a problem, and in this situation, you're like, okay, what is changing? Well, there's 2 things that are changing. You have the number of cars that you buy, and then the total cost of the cars. So the 2 things that are changing, that would be your variables, would be your number of cars and then the money, the total cost. And so then you look at the other idea that we look in writing algebraic expressions, and we look at what we call a constant. And a constant stays the same. So when I look at a constant, something that stays the same, the thing that's staying the same here is your $8 per car. Your price is staying the same. That is your constant. So then you're thinking, okay, which variable quantity depends on the other variable quantity? So you're looking at these 2 variables, and what you're going to do is you're going to call one the dependent and one the independent variable. The number of cars is independent. That you just kind of choose. So this is independent. That's your independent variable. And then the cost of cars depends on how many cars you buy. Depending on how many cars, it's going to change the cost. So this is your dependent. So this is your dependent variable. This one's independent. This one can be whatever you choose, and then this one is going to change depending on what you choose for the number of cars. So finally we come down and we want to write an algebraic expression that basically explains the relationship for like the cost. We'll say the cost in dollars is going to equal, the C is going to equal with how many cars. So basically, I know it's going to be 8, and then say I have n cars, it's going to be 8n, 8 times n, or 8 times the number of cars. So this would be the algebraic expression that how many ever cars I choose to buy, I can determine the cost just by plugging it into this expression. Here I want to go through a couple examples. While you're watching this video, a good strategy would be, once I kind of explain what I'm going to do with each example, maybe pause the video and work them out on your own and then compare to what I do. So the first example, we're going to look at the sequence of numbers here. 2, 4, 6, 8. And I think, what's changing the number? See, 2 plus 2 is 4. Plus 2 more is 6. Plus 2 more is 8. So I'm adding 2 each time. But like if I'm thinking like 1, 2, 3, 4, how do I get from this, which would be n would be 1, 2, 3, or 4, to this? How do I get 1 to equal 2, 2 to equal 4, 3 to equal 6, 4 to equal 8? Oh, well, 4 times 2 is 8, 3 times 2. So it ends up being 2n. So this is 2 times n. This is similar to the one where we had 8 times n with the cars. This one here. So 1, 3, 5, 7. So in this case, we're looking at, this is term 1, this is term 2, this is term 3, this is term 4. This is a more complicated one because I'm thinking, okay, how do I get from 1 to 1? Well, I could multiply by 1, okay, but then 2 times 1 does not equal 3, okay, and 3 times 1 does not equal 5. What if I did like 2 steps? What if I multiplied, let's see, multiply by 2, so let's see, 1 times 2 equals 2, and then how do I get from 2 to 1? Take away 1 equals 1. Okay, so let's see if that works. Let's do 2 times 2, that equals 4, minus 1 equals 3. So that gets me from 1 to 1, 2 to 3. Let's try it for 5. 5 times 2 equals, 3 times 2 equals 6, minus 1 equals 5. And then the next one would be 4. 4 times 2 for the fourth term, when n equals 4, multiply by 2. I'll get 8, I subtract 1, and I get 7. So 1, 3, 5, 7. So this would do it. That means that I'm multiplying by 2, so it'll be 2n, and then I subtract 1. So my algebraic expression is 2n minus 1. This pattern here, this series, this sequence, is 3, 5, 7, 9. So those look kind of like just like odd numbers, but I think, how do I get from 1 to 3, 2 to 5, 3, and 4? So 1 to 3, I'm thinking about this 2n thing, like, oh wow, if I do 1 times 2, 1 times 2 is 2, and then I add 1, I get 3. 2 times 2 is 4, plus 1 is 5, times 2 is 6, plus 1 is 7, then I bet you 4 times 2 is 8, plus 1 is 9. So it's times 2 plus 1 in this case, where the other one was times 2 minus 1. So it'll be 2n plus 1, and that'll get me to my answer there. This next one is a little bit tricky. 2, 4, 8, and 16. So when I think about this, I'm just looking for the pattern. 2, 4, 8, 6. So how do I get 1 to 2? How do I get 1 to 4, 1 to 8, and 1 to 16 by doing the same thing every time? Or 1, 2, 3, 4. This one is about understanding things like, this is getting big really fast, like 2 to 4 to 6 to 8. So how do I get from 2 to 4? Well, if I do 2 times 2, I get 4. And I do 4 times 2, so I'm doing times 2. 4 times 2 is 8. 8 times 2 is 16. So every time I'm multiplying the term before by 2, which means ultimately 2, I'm not multiplying by 2 at all, which means I'm doing 2 to the first. And then for 4, I'm doing 2 squared. And then 8 would be 2 to the third and 2 to the fourth. So your term, or the n, is actually going to be your exponent. 2 to the first, 2 times itself once is just 2. So my expression becomes 2 to the n. And that's, again, if you're multiplying each term to get to the next one, you're probably looking at an exponent. Whereas if you're adding each term to get to the next one, you're probably looking at multiplication. Now, we're going to go over an example that's addition here. In this case, you have addition. And then when you look at addition, it basically just looks like you're counting, like 101, 102, 103, 104. So it looks like you're counting. So I basically am taking n, 1, 2, 3, and 4, like the term. The term is n. So n, 1, 2, 3, or 4, plus, well, to get to 101, I add 100. 102, I add 100. Plus 100 gives me 103. Plus 100 would give me 104. So n plus 100 would be your expression for this sequence. Okay, I want to kind of go over some like vocabulary you're going to hear when talking about algebraic expressions. The first thing you're going to talk about is variables, and those are going to be the letters that are written in the algebraic expression. You're always going to have at least one, otherwise it's not an algebraic expression, it's just an expression. So there's always going to be at least one. That's just it's a number or something that's represented by a letter that can change. Numbers are going to be the things that are going to be your constants. You'll see in there operations will be addition, subtraction, multiplication, or division. Remember that sometimes multiplication can be written like this, and division can be written like this. Also, the dot can be multiplication as well. Terms, those are the different parts of your expression. So a term of algebraic expression is going to be a number, a variable, or a product of numbers and variables, or maybe even a quotient here. So let me show you an example. So right here in this algebraic expression, we end up with two variables. The variables are x and y. So those would be our variables. We actually end up with 3 terms. 3x, or 3 times x, is one term, 4 times y is a second term, and 7 is a third term. And then we end up with 2 operations. We have addition and we have subtraction within this expression. So just kind of the different parts here. So our first term is saying 3 multiplied by x, the second term is saying 4 multiplied by y, and the last term is 7. Now in between it's saying to add and to subtract, which you would use your order of operations if you're trying to evaluate this once you've determined variables. So let's compare these two expressions. You have 8 plus 5x and 8 minus 5x. So let's just look at like your terms. How many terms does each one have? Well, this one has 2, 8, and then 5x, and this one has 2, 8, and 5x. So wait, like the terms are actually both 8 and 5x, 8 and 5x. Okay, so the same from these is you have the number of terms and the terms themselves are both the same. Now, if you look at what's different about these, which is a pretty critical difference, is you have a different operation. In the first one, you're adding, and then in this one, you're subtracting. So it's going to be a critical difference in terms of this, in terms of looking at these two algebraic expressions. Take a look at like this algebraic expression and just look at it like, oh, let's look at what the terms are here. So in this one you have like your first term would be 7b, your second term would be 9x, third term would be 3a, and then your last term would be the constant of 12. And obviously these have variables in them because you have x, a, and b that are all variables and can change, will be whatever they need to be depending on what this is what this situation is actually representing. So again, in this case you're looking at 4 terms. 1 constant, and 3 variables. And these variables each have like a number in front of them and just kind of a side here. These numbers, like 7 times b, 9 times x, and 3 times a, these are what we call coefficients. And we'll talk about this again in some later lessons. So I'm going to kind of like think of some stories. And in those stories, I want you to think of like how this would be representative of like in algebraic expressions. In an algebraic expression, say for example you have chairs, right? And the chairs cost $35 for chairs. But you also have sofas, and the sofas cost $75. How much would it cost to purchase X chairs and Y sofas? Oh, okay, well, I need to do the price times the number I buy, so 35x. I'm going to have to just add that to the number of sofas times the price, 75y. So the algebraic expression would be 35x plus 75y would help me figure out that problem. Or say I'm going to rent a storage area, like I'm going to rent a storage unit, and the cost of that is $125 for the unit. But it's going to be shared equally among the number of people that share it. And those people would be P, so they're going to share it equally. How much would each person pay? Well, if it's $125 and then you're going to divide it into P people, it's 125 divided by P, otherwise written as 125 over P as a fraction, because again, you can always write division as a fraction just like this. So there's just some examples of some more word problems where you basically are taking a real-life example and trying to create an algebraic expression. So hopefully now you're better able to answer the question, how can I write an algebraic expression to determine the next term in a sequence? So we're going to be given some situations in class where I'm going to ask you to write an algebraic expression that will represent that situation and help us determine the terms in the sequence of it.